Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that CD equals to 2 units, BC equals to 8 units. We also know that DE is parallel to AB, and G is the centroid of triangle ABC. What is centroid? Centroid is a point that the three medians of the triangle are intersect with each other. And we also know that DE, or the size of DE, belongs to the natural number. That is to say, DE is a natural number, and we have to find out the value of DE, that is natural number. Okay, so first of all we have a rule. The rule states that in any triangle actually if we have triangle ABC, that can be any triangle, and we know that G is the centroid of the triangle, and AD is the median of BC. Line segment AD is the median of BC, that is to say AD bisects BC, or in other words, AD divides side BC of triangle ABC to two equal parts, that is to say BD equals to DC. And we know that G is the centroid of triangle ABC. Then actually the centroid G divides the median AD in a relationship that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1. Okay? Or in other words, AG equals to 2 times GD. Okay, so according to this rule, the centroid G divides the median AD in such a relationship that AG equals to 2 times GD, that is to say AD is twice as large as GD. Okay? And if we define AG, then we actually can implement that rule in our triangle ABC. In our triangle ABC, we know that G is the median of triangle ABC, and G is the centroid of triangle ABC. Therefore, CG will be equal to 2 times GF, according to this rule, the centroid G of triangle ABC divides the median CF in a relationship such that CG equals to 2 times GF. And if we define CG as 2x, if CG will be equal to 2x according to our definition, then we will substitute CG in this equality by 2x, and we will get that 2x equals to 2 times GF. We will divide this equality by 2, and we will get that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. Okay, so if CG equals to 2x, if CG equals to 2x, then GF will be equal to x. Okay, then we actually have another rule that is also applied in any triangle. So in any triangle, if we have triangle ABC that can be any triangle, and we know that DE is parallel to BC. So if we know that in triangle ABC DE is parallel to BC, then according to the second rule, AD over DB, AD over DB equals to AE over EC, equals to AE over EC. So I will repeat again. This is triangle ABC that could be any triangle. So if we triangle ABC, we know that DE is parallel to BC, then the following relationship exists between the sides of the triangle. That is to say, AD over DB, AD over DB equals to AE over EC. And we can implement the second rule in our drawing. Because we know that DE is parallel to AB. According to what is given us in the question, DE is parallel to AB. So, because of the fact that DE is parallel to AB, so according to that rule, according to this rule, we can conclude that the following relationship exists between the sides of the, or if we relate to triangle ACF, if we relate to triangle ACF, because of the fact that DE is parallel to AB, we know that in triangle ACF, CD over DA will be equal to CG over GF. Again, according to the rule that I mentioned, in triangle ACF, because of the fact that DE is parallel to AD, it is true to say that CD over DA equals to CG over GF. But what is the value of CG? CG equals to 2x, and we also know that GF equals to x. Okay, we know that CG equals to 2x and GF equals to x, so 2x over x is 2. 2x over x is 2. So we actually found out that CD over DA equals to 2, and if we multiply this equality by DA, we will get that CD equals to 2 times DA. Okay? And if we define CD as 2y, that is to say CD equals to 2y, so we will substitute CD by 2y, we will get that 2y equals to 2 times dA. Then we will divide this equality by 2 and we will get that dA equals to y. dA equals to y, so we actually found out that if CD equals to 2y, then dA equals to y. Again, if CD equals to 2y, if CD equals to 2y, then dA equals to y. Okay? So we know that CD equals to 2y and dA equals to y. And we have another rule. The rule states that corresponding angles between parallel lines are equal to each other. Okay? I write down the rule. The rule states that corresponding angles between parallel lines are equal to each other. I will read the rule again. The rule states that corresponding angles between parallel lines are equal to each other. We actually can implement that rule in our drawing because of the fact that we know that DE is parallel to AB. We know that DE is parallel to AB. So according to this rule, the corresponding angles will be equal to each other. So here we know that DE is parallel to AB. Therefore, the corresponding angles actually those two angles will be equal to each other because DE is parallel to AB. Therefore, the two corresponding angles that are actually alpha those two corresponding angles those two corresponding angles will be equal to each other. Again, because of the fact that DE is parallel to AB, therefore those two corresponding angles will be equal to each other. Okay, those two corresponding angles will be equal to each other. So if we define angle BAC as alpha, then angle CDE will be also equal to alpha. So I'll write it down. Because of the fact that DE is parallel to AB, according to this rule, the corresponding angles will be also equal to each other. That is to say, angle BAC will be equal to angle EDC or CDE. And if one of the angles equals to alpha, then the other angle will be also equal to alpha. Okay? According to the rule that states that corresponding angles between parallel lines are equal to each other. DE is parallel to AB, therefore those two corresponding angles will be also equal to each other. And for the same reason, because of the fact that DE is parallel to AB, then those two corresponding angles will be also equal to each other. Those two corresponding angles will be also equal to each other. That is to say, angle CBA will be equal to angle CED. Okay, those two angles will be equal to each other, and those two angles will be equal to each other, and if we define one angle as beta, then the other angle will be also equal to beta, because those two angles are equal to each other. Okay? So according to the same rule that corresponding angles between parallel lines are equal to each other, angle CBA equals to angle CED, and both those two angles are equal to beta. Those two angles are equal to each other, and they are both equal to beta. And we also found out that those two angles are also equal to each other, and both are equal to alpha. Okay? So, in the next step, we will focus on triangles ABC and triangle CDE. Okay? We will focus on triangles ABC and triangle CDE. In those two triangles, we know that angle CAB in triangle ABC is equal to angle CDE in triangle CDE, and they are both equal to alpha. Okay, those two angles are equal to each other, they are both equal to alpha. Angle CAB equals to angle CDE, and they are both equal to alpha. And we also know that angle CBA is equal to angle CED. Those two angles are equal to each other, and they are both equal to beta. So angle CBA is equal to angle CED, and they are both equal to beta. Okay, angle CBA equals to angle CED, and they are both equal to alpha. And we also have the third angle, angle C. This angle C, it is actually a common angle, it belongs to both triangles. So we can write down that angle C equals to angle C. Angle C equals to angle C is a common angle. Angle C equals to angle C, it is a common angle. So we actually proved that all the angles of triangle ABC are equal to all the angles of triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. So I write it down. Triangle ABC is similar, that is the sign of similar, to triangle CDE according to angle similarity rule. Okay, triangle ABC is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? If you prove that all the angles of one triangle are equal to all the angles of the other triangle, then you actually prove that the two triangles are similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC or CD over CA is equal to DE over AB. So I will repeat again, from the fact that triangle ABC, the big triangle, is similar to the small triangle CDE, we can conclude that CD over CA equals to DE over AB. Okay? But what is the value of CD? The value of CD of CD is actually 2y. The value of CD is 2y. And what is the value of CA? CA equals to 2y plus y. That is to say to 3y. So in total we got this equality. And actually 2y over 3y is 2 over 3 because y will get cancelled because y over y is 1. So in total we will get that dE over AB equals to 2 over 3. Here we will multiply this equality by AB and we will get that dE equals to 2 over 3 times AB. We found out that dE equals to 2 over 3 times AB. Okay? And we actually have another rule. If we have a triangle ABC that can be any triangle, so if in triangle ABC we know that the size of triangle, the size of side AB in triangle ABC is A units, the size of side AC in triangle ABC is B units, and the size of side BC in triangle ABC is C units. Then we know that the side of a triangle will be always smaller than the size of the sum of two sides, or the size of one side of the triangle will be always smaller than the size of the sum of the two other sides. That is to say, BC, that is actually C, will be always smaller than the sum of the two other sides. That is to say, it will be smaller than A plus B. Again, the size of BC, that is C units, will be always smaller than the sizes of the other two sides, that is to say A plus B, and it will be always greater than the difference between the two other sides. That is to say, it will be smaller than the difference between the two sides, that is actually A minus B, the absolute value of A minus B. Again, this rule actually states that the sum of two sides in a triangle is always greater than the length of the third side, and it also states that the difference between two sides of a triangle will be always smaller than the length of the third side. Okay, so we can implement this rule in our triangle ABC. If we relate on AB, we know that AB, that is actually the length AB of triangle ABC, will be always small than the sum of the two other sides of the triangle. That is to say, it will be always smaller than AC plus CB. And it will be always greater than the difference between the two other sides, that is to say AC minus CB. AC minus CB, the absolute value of AC minus CB. According, this expression is actually the implementation of the rule that I stated in our triangle ABC. So we know that AC equals to 2 units and CB equals to 8 units. So we can write here that AB will be greater than 2 minus 8, the absolute value of 2 minus 8, and it will be smaller than 2 plus 8. Or AB will be smaller than 10, 2 plus 8 is 10, and it will be greater than the absolute value of minus 6 is 6. So we found out that AB is greater than 6 and it is smaller than 10. The absolute value is actually the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. Okay, but we have already found out that the value of DE is actually 2/3 AB. Okay, so we will multiply this expression by 2/3 and we will get that 2/3 AB is smaller than 2/3 times 10, and it is greater than 2/3 times 6, or 2/3 AB is smaller than 2 times 10 is 20, and 20 over 3 is 6.66, and it is greater than 2 times 6 is 12, 12 over 3 is 4. So we found out that 2 times AB is greater than 4, and it is smaller than 6 times, than 6.66. But we know that 2/3 AB is dA. 2/3 AB equals to dE, so we can substitute 2/3 AB by dE in this expression. Okay? And we will get that dE is greater than 4, and it is smaller from 6.66. Okay, we substitute that 2/3 AB by dE, and we got this equality. But we also know it is given us in the question that dE is a natural number. dE belongs to the natural numbers. dE belongs to the natural numbers. So which natural numbers we have that are greater than 4 and smaller than 6.66? The only two numbers that we have are 5 and 6. So dE will be equal to either 5 or 6. So the answer to the question is that the size of DE, of this line segment DE, is either 5 units or 6 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the value of DE, and we know that AC equals to 2 units, CB equals to 8 units. We also know that DE is parallel to AB, and we know that G is the centroid of triangle ABC. So what is centroid? Centroid is a point that the three medians of the triangle are intersect with each other. And we also know that dE belongs to the natural numbers, that is to say dE is a natural number, and we want to find out the value of dE. So we actually have a rule that is true for any triangle. In triangle ABC, that can be any triangle. If G is the centroid of triangle ABC and AD is the median of triangle ABC, or AD is the median of BC, that is to say AD bisects BC, or in other words, AD divides BC to 2 equal parts, that is to say BD equals to DC, then actually the centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Or in other words, AG is 2 times larger than GD. Okay, AG is 2 times GD. So we can implement this rule in our triangle ABC. We know that G is the centroid of triangle ABC. Therefore, the centroid G divides the median CF in a relationship that equals to 2 to 1. If CG equals to 2 units, then GF will be equal to 1 unit. Okay? Or in other words, CG is twice as large as GF, or CG equals to 2 times GF. And if we define CG as 2x, that is to say CG equals to 2x, then we will substitute the value of CG by 2x, and we will get that 2x equals to 2 times GF. We will divide this equality by 2, and we will get that GF equals to x. So we found out that if CG equals to 2x, then GF equals to x. So we can write here that if CG equals to 2x, then GF, if CG equals to 2x, then GF will be equal to x. Again, if CG equals to 2x, then GF will be equal to x. Okay? And we also have another rule that it is true in any triangle. In any triangle, if we know that in triangle ABC, line segment DE is parallel to BC, then the following equality is true, that AD over DB equals to AE over EC. Again, in triangle ABC, if we know that DE is parallel to BC, then AD over DB will be equal to AE over EC. And again, we can implement this rule in our drawing, in our triangle. If we relate to triangle CAF, we know that in triangle CAF, DE is parallel to AB. So according to the rule that I stated 1 minute ago, CD over AD will be equal to CG over GF. In triangle ACF, because of the fact that DE is parallel to AB, then CD over DA will be equal to CG over GF. But we know that the value of CG is 2x and the value of GF is x. So we can write here that CG equals to 2x and GF equals to x. And 2x over x is 2, because x over x is 1, x will get cancelled, then 2x over x is 2. So we found out that CD over DA equals to 2, and if we will multiply this equality by 2, we will get that CD equals to 2 times DA. CD equals to 2 times DA, and if we define CD as 2y, that is to say CD equals to 2y, then we will substitute CD by 2y, because CD equals to 2y. So we will get that 2y equals to 2 times dA, and we will divide this equality by 2, and we will get that dA equals to y. So we found out that if CD equals to 2y, then dA equals to y. So we can write here that if DC equals to 2y, then AD will be equal to y. Okay? If CD equals to 2y, then dA will be equal to y. Okay, and we also have the rule that states that corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. And we know that DE is parallel to AB. Therefore, the two corresponding angles, those two corresponding angles will be equal to each other. So if this angle is alpha, this angle will be also equal to alpha. Or angle BAC will be equal to angle CDE will be equal to alpha. Okay, and we have the same rule also in the other side of the triangle. We know that DE is parallel to AB, therefore those two corresponding angles will be equal to each other. That is to say, angle CBA will be equal to angle CED, and if one angle equals to beta, then the other angle will be also equal to beta. Okay, so angle CBA equals to angle CED, and both are equal to beta. Okay. Then we focused on the triangle ABC, the big triangle ABC, and on the small triangle CDE. Okay, we focused on triangle ABC and on triangle CDE. On those two triangles, we know that those two angles are equal to each other. They are both equal to alpha. So angle CAB equals to angle CDE equals to alpha. And we also know that those two angles are also equal to each other. They are both equal to beta. Or angle CBA equals to angle CED equals to beta. And this angle C, is a common angle. It belongs to both triangles. So angle C equals to angle C. It is a common angle. It belongs to both triangles. So we actually proved that triangle ABC, all the angles in triangle ABC are equal to all the angles of triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. What is angle similarity rule? Angle similarity rule is actually a rule that states that if you prove that all the angles in one triangle are equal to all the angles of the other triangle, then you prove that those two triangles are similar to each other according to angle similarity rule. Okay? So because of the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Again, because of the fact that DE is similar to, because of the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Okay, CD over CA equals to DE over AB. But what is the value of CD? CD equals to 2y. And what is the value of AD? AD equals to y. So we can write here that CD equals to 2y and CD equals to 2y, but the value of CA is actually CD plus DA. So CA equals to 2y plus y. CD equals to 2y plus y, that is to say to 3y. So CD equals to 2y and CA equals to 3y. Okay, and 2y over 3y is 2 over 3 because y over y is 1. So y will get cancelled. We found out actually that DE over AB equals to 2 over 3, and if we multiply this equality by AB, we will get that DE equals to 2 over 3 times AB. DE equals to 2 over 3 times AB. Okay? And then we have another rule. If we have triangle ABC, and we know that the size of side AB is A units, the size of side AC is B units, and the size of side BC of triangle ABC is C units, then C will be smaller than A plus B, and it will be greater than A minus B, or it will be greater from the absolute value of A minus B. So we can implement this rule in our triangle ABC. If we relate to side AB on triangle ABC, we know that AB will be smaller than the sum of the two other sides, that is to say, will be smaller than AC plus CB, and it will be greater than the difference between the two other sides, that is to say, it will be greater than AC minus CB. And we know that AC equals to 2 units and CB equals to 8 units. Okay, so 2 plus 8 is 10, 2 minus 8 is minus 6, and the absolute value of minus 6 is 6. What is the absolute value? The absolute value is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6. So we got the equality that AB is greater than 6 and it is smaller than 10. But we have already found out that DE equals to 2/3 times AB. So we will multiply this expression by 2/3, and we will get that 2/3 AB equals to 2/3 times 6. It actually 2/3 AB is greater than 2/3 times 6, and it is smaller than 2/3 times 10. 2/3 times 10 is 6.66, and 2/3 times 6 is 4. But what is the value of 2/3 AB? According to this equality, 2/3 AB equals to DE. So we can substitute 2/3 AB by DE. Okay, so we substitute the 2/3 AB by DE, and we got that DE is greater than 4 and it is smaller than 6.66. But we also know that DE belongs to the natural numbers. That is to say, DE is a natural number. So which natural numbers we have that are greater than 4 and that are smaller than 6.66? The only two natural numbers that are greater than 4 and that are smaller than 6.66 are 5 and 6. So we found out that the size of DE is either 5 units or 6 units. Again, the size of line segment DE equals to either to 5 units or to 6 units, and that is the answer to that question. Okay, thank you very much.